In programming, some concepts are basically superpowers. And today, we're going to unlock one of the biggest ones: how to automate repetition using loops. I mean, we've all said it, right? I feel like I'm stuck in a loop. You're just doing the same thing over and over again. Well, it turns out that super common, very human feeling, it's actually the perfect key to understanding one of the most fundamental tools that makes computers so incredibly powerful. I mean, think about it. Our lives are just filled with loops. Your daily routine is a perfect example. You wake up, you eat, you work, you sleep, and then what? You repeat. It's like a real-world algorithm that we just run every single day. And this right here, this gets to the absolute heart of why loops are such a game changer. For us humans, doing the same thing over and over is just draining. We get bored, we start making silly mistakes, we're slow. But for a computer, repetition is its superpower. It can do the same task billions of times without ever getting tired, without a single error, and at speeds we can't even imagine. That's the incredible power we're going to tap into today. Okay, so here's the plan. We'll kick things off with why we even need loops. Then, we'll meet the two big players, for loops and while loops. After that, we'll get into how to master them. And finally, we'll put them to work and see some real magic happen. All right, section 1, why do we even need loops? Well, it's all about turning those really tedious tasks into pure automated power. Okay, before we go any further, there's one key word we've got to know: iteration. Now, I know it sounds a little technical, but trust me, it's super simple. Iteration is just the act of repeating a block of code. So one single pass through a loop, think of it as one lap around the track, that's one iteration. See? Easy. All right, let's meet our first major tool. This is the for loop. You can really think of this as the trusty workhorse of your programming toolkit. It's the one you're probably going to reach for most of the time. So when do you actually use a for loop? The rule of thumb is dead simple. You use it when you know the exact number of times you need to do something. It's kind of like telling someone, run the track 10 times. That's it. It's a specific, fixed command. Not 9 times, not 11 times. Exactly 10. You know the number of laps before you even start running. And every for loop has this neat little 3-part structure. First, there's the initialization. That's where you set up your counter, like setting it to 0. Second, you've got the condition. This is what the loop checks every single time to see if it's done yet. And third, there's the update. This is what changes the counter after each pass, usually by adding 1. So it's this really elegant cycle: start, check, update, and repeat. But what happens when you don't know how many times you need to repeat something? What if you don't know when to stop? Well, that brings us to our next section and our second kind of loop, the super flexible while loop. This one is built for dealing with uncertainty. And the rule for using a while loop is basically the exact opposite of the for loop. You grab this tool when you don't know ahead of time how many repetitions you'll need. The loop just keeps on going as long as a certain condition is true, not based on some fixed number. Let's go back to our runner on the track. If the for loop was run 10 times, the while loop is more like, hey, while you're not tired, just keep running. See the difference? The loop has no idea if you're going to run 1 lap or 100. All it does is check that condition. Are you tired yet? Before every single lap. Now, there's a little variation here that's really important. A standard while loop checks the condition before the code runs. So if the condition is false from the very beginning, the loop might not run at all. Not even once. But there's also something called a do while loop. This one runs the code first and then checks the condition. What does that mean? It means it's guaranteed to run at least 1 time. Okay, so you've got the basics down. You know about for and while. Now it's time to level up. Section 4 is all about mastering your loops. We're talking about taking more precise control and, maybe more importantly, learning how to avoid one of the most common traps in all of programming. So inside a loop, you've got 2 special commands. First up is break. Think of break as your emergency eject button. The second you hit it, you're out. The loop terminates immediately. Done. Then you have continue. This one's different. It doesn't end the whole loop. It just says, okay, I'm done with this current lap, skip the rest of it, and jump straight to the start of the next. So we know how to break out of a loop when we want to. But what happens when a loop has no end? What if you accidentally create a loop that just never stops? Well, then you get what's called an infinite loop. And this is the classic programmer mistake. It's when the loop's exit condition is just never, ever met, so it runs forever and ever, and can totally freeze your program. And what's the number one cause? 9 times out of 10, it's forgetting to update your counter. If you never add 1 to your counter, well, it's never going to reach its target, right? Okay, now for the really fun part. Section 5, let's actually put these loops to work. This is where we see what happens when we combine these simple building blocks to create something way more interesting.
So, did you know you can actually put a loop inside of another loop? Yeah, it's called a nested loop, and it's an amazing technique for building things in 2 dimensions, like a grid with rows and columns.
Let's watch this in action. We're going to build a simple triangle. So the outer loop is going to be in charge of the rows. On its very first run, it starts up and it tells an inner loop, hey, just run 1 time. And that inner loop prints a single star. Okay, now the outer loop goes around for a second time. In this time, it tells the inner loop to run twice. So boom, we get 2 stars. Are you starting to see the pattern here? The outer loop handles the number of rows, the height, and the inner loop handles how many stars go in each row, the width. And it just keeps going like that. The next time the outer loop runs, the inner loop prints 3 stars, then 4, and so on, until the whole triangle is finished. That is the real magic of nested loops. You have these very simple rules that end up creating these cool, complex patterns. And drawing triangles is just scratching the surface, you know? Loops are the invisible engine that powers so much of our digital world. They're what's processing massive data files, what's handling web requests for millions of users at the same time, what's running thousands of automated tests to make sure our apps don't break. They are literally everywhere, just working away tirelessly behind the scenes. So that's really the heart of it. Loops take a boring, repetitive human task and turn it into a lightning-fast, flawless, automated process. Which, leaves me with one final question for you. Now that you get the incredible power of automating repetition, what's the very first tedious task in your life that you teach a computer to do for you?